Hi everyone, welcome back to another clip on solving the sine and cosine of the obtuse and acute angles. So as you can see from the title of this clip, this is the part 2. The first part can be seen at the same playlist. So let's continue. We have here in our screen there are two triangles. So earlier we don't have to use calculator and we just have to work on the data given to us. But here maybe you can find it, or maybe you have tried it on your own school or your own worksheets. You have this as the data instead of working with the angles straight away. So let's try to solve on the left part of the picture of the screen first. We have a right angle triangle. The combination is clear. I believe you this is the popular combination, 3, 4, and 5 as the hypotenuse. Okay, and the data is everything is there. Yeah, this is the vertex A, B, C, and then D is the extension of B and C. And we are asked to find sine ACD. Okay, so remember that sine acute and sine of the obtuse pairing will be exactly the same and both of them will be positive. While the cosine A and the pairing of obtuse angle of that, the obtuse will be negative and the cosine of the acute angle of that pairing will be positive. While the value is kind of the same, only the negative and positive that we have to carefully check that. Yeah, so just remember obtuse cosine will be negative, while the remaining will be positive, only in sine and cosine first. Yeah, so again, we're going to start that sine ACD. So ACD. So ACD is actually this one. Yeah, this angle. Yeah, so as you can see, this is an obtuse angle. So that means we need to find the pairing, which is this one. This is the acute part. So actually, sine ACD will be the same of sine ACB. Yeah, so you're going to solve that straight away. Sine ACD equals to sine ABC. Remember, SOH, yeah, as SOH CAH TOA, SOH, sine, opposite over hypotenuse. So which one is the opposite of the angle? So the opposite will be always the opposing side. So this is going to be the 3 and hypotenuse will be 5. So let's put that on our questions over here. So the answer is 3/5. Next, we are asked to find out the, okay, sorry about that. I misclicked this, so I'm going to close it for a while. And then we are going to have, we're going to find cosine of ACD this time still. So this is our obtuse, yeah, and this is our, yeah, this is our acute pairing of that. So that means, remember, but it has to be negative, yeah. So cos ACD is actually the negative of cos ACB. Yeah, okay, so I made a mistake on this one. Yeah, always be careful on writing your angles. So this is going to be negative cos ACB and cosine, so CAH. CAH stands for cosine equals to adjacent over the hypotenuse. So ACB, this is our angle, and our adjacent will be this. our hypotenuse will be this one. But don't forget to include negative because we are talking about this. Yeah, we are talking about the obtuse angle. So therefore, the value has to be negative 4/5. Okay, I'm going to extend this box a bit so it's going to be neatly organized over here, although it's not very organized. Okay, we're going to move on. We are asked now to find tangent of BAC. Okay, let's look at the picture once again. BAC. So this is the one. Remember, SOH CAH TOA. TOA. T tangent equals to opposite over adjacent. So which one is the opposite of this one? Of course, is this side. Yeah. And then adjacent. Is it going to be here? No, this is a hypotenuse. So it's going to be this one. So let's put that on our text box over here. It's going to be 4 out of the 3. Or we can make it 1.333. Okay, we're going to correct it to 3 decimal points. Okay, and that's how you solve the relationship between sine and cosine of the obtuse angle. Okay, so we're moving on to this one. This is already presented in a graph. Yeah, basically we are facing the same thing, but this is presented in a graph. That's it. Yeah, we have in our screen the same right angle triangle, but this time we have this in the only the table and then the lines. Yeah, so before we find out sine HBC, we have to know what first. Okay, all right, we can count the leap. Yeah, we can count it from negative 4.1 to negative 4.6. Obviously there is 5 leaps over here, and then from 1, okay, I'm going to activate my pointer, from 1 over here, negative 4.1 to 8.1. So there are 12 leaps, as you can see from here, negative 4 to 8, and then over here, 1 to 6. So 5 over here, 12 at the adjacent. Do you remember how to work on or how to find out the hypotenuse? The relationship is going to be the same. So we need to solve that first. Okay, I'm going to move this here, so I'm going to put that over here. So the hypotenuse is actually the square root of 5 squared. 5 squared is actually 25, and then 12 squared is 144, and it will be equals to 169. 169, but this is the square of it, so we need to find the square root. So we have oops, I need to go back. So therefore the square root of it, we're going to put it like this. If you know how to incorporate mathematical formula in this OpenBoard, because I'm still new to this one, I need you to comment, on the comment section, so we can exchange some information regarding to this, so I can always improve my video for everyone. So square root of 169 is actually 13 units. So we know we have to deal with this one first. I'm going to okay, much better. Right. And then I'm going to make it like this. Yeah. Right. So because we know that this is 5, 12, and 13, now hopefully we can work on the solving sine HBC a little bit easier. Yeah. So HBC, take a look on that. H, B, and C over here. So this is the one that we need to find out. Which one is the acute pairing? Yep, this is correct. So it's going to be ABC. Let's put it there first. Equals to sine ABC. Sine ABC, remember, SOH CAH TOA. So it's going to be opposite, the opposite of ABC, B. The opposite is going to be this side, yeah, and then the hypotenuse obviously is this one. So the answer will be 12 over 13. Yeah. And what about if we are going to find out cosine of B, C, and K? B, C, K. Yeah. Let's take a look at our graph. BCK is actually this obtuse angle, and then the pairing, obviously this side. Yeah, this vertex is the pairing of BCK. But remember, cos of an obtuse angle will be negative. So therefore, we are going to put that here equals to cosine ACB. Cosine ACB. So C is adjacent over the hypotenuse with the negative 12 over 13. Right. And then last, what happened if the question is asking about tangent of ABC? Okay, tangent of ABC will be on this side, yeah, this vertex. And remember, tangent, you can have the tangent of an angle by dividing the opposite over the adjacent. So the opposite will be this one, and the adjacent will be this one. Yeah, this side. So it's going to be, okay, 12 over 5. It's going to be 2.4. And that's how you solve sine and cosine of the obtuse and acute angles if the data is presented on a drawing or on a graph like this one. Hopefully you can make use of this clip well. See you soon.